All right, let's pull back the curtain on artificial intelligence and really get into how machines actually learn. We're going to follow the entire journey, right from a simple idea all the way to a smart, functioning AI system. So let's dive in. We see AI pop up everywhere, but how does that actually happen? How does an idea transform into something we call intelligent? Well, I can tell you it's definitely not magic. It's a really methodical, step-by-step process. And in this explainer, that's exactly what we're going to do. Walk through that entire journey together. So here's our roadmap. We've broken the whole process down into 4 key phases. First, there's the blueprint, which is all about laying that solid foundation. Then we move into the lab. That's where the model gets built and put through its paces. After that, it's the launch, when it finally goes out into the real world. And last but not least, the long haul. Because as you'll see, a model's work is never really finished. Okay, first up, the blueprint. It's just like building a house, right? You can't just start putting up walls without a solid plan and the right materials. This first phase is all about defining what you're trying to do and getting your data in order. And believe me, if you get this part wrong, the whole project can just fall apart later on. Everything starts with translating a big, kind of fuzzy business idea into a super specific, measurable machine learning goal. So for example, Google's big business objective might be make Gmail the #1 email service in the world. That's the vision. But the machine learning goal that supports it is way more concrete. Build a model that can tell the difference between your primary emails and promotions with more than 90% accuracy. One's a dream, the other is a job to be done. So, once you've got that clear goal, you need fuel for the engine, and that's data. But here's the thing, raw data is almost always a mess. So this whole stage is about collecting it, cleaning it up, and organizing it into a nice, tidy format that a machine can actually understand. And then, and this is so important, you split that precious data into 3 different buckets. One to train the model, one to validate it as it learns, and a final untouched set to test how well it performs on information it has never, ever seen before. And that leads us to one of the most creative, kind of artistic parts of this whole process, what we call feature engineering. See, a machine learning model has no idea what Monday means, or the color blue, or what a 5-star review feels like. It only speaks one language, and that language is numbers. So the engineer's job is to be a translator, turning these real-world ideas into a numerical format. Now check this out, because this is a brilliant example of how that works. How do you teach a machine about the days of the week? You can't just label them 1 through 7, right? Because that implies that Sunday, number 7, is really far away from Monday, number 1, which we know isn't true. So instead, engineers use a clever math trick with sine and cosine. It basically turns the week into a circle, so the model understands that Monday always comes right after Sunday. It's a really elegant way to teach a machine a very human concept. So what's the big takeaway from this whole blueprint phase? It's really simple. Your model is only ever going to be as good as the data and the features you feed it. Without a clear goal and really well-prepared, thoughtfully designed data, even the most powerful algorithm on the planet is going to fail. It's that classic saying, right? Garbage in, garbage out. Okay, our blueprint is solid, our materials are ready. Now it's time to head into phase 2, the lab. This is where we actually build the thing. This is where the model gets forged and tested, and where the learning part of machine learning really happens. Now, the absolute central challenge when you're training any model is navigating something called the bias-variance trade-off. The best way to think about it is trying to find the perfect balance. You don't want a model that's so simple it misses the whole point, but you also don't want one that's so ridiculously complex that it just gets lost in all the random noise. And this slide just perfectly illustrates those 2 extremes. On one side, you have high bias. That's a model that's way too simple. It's like trying to draw a beautiful curve using only a straight ruler. It just completely misses the underlying pattern. On the other extreme, you have high variance. This model is so complex that it basically memorizes every single little data point, including all the random static. It's a perfect fit for the data it's already seen, but it's totally useless for predicting anything new. The goal, the real art, is landing right there in that sweet spot in the middle. So how do we actually find that sweet spot? Well, we do it through a ton of evaluation. First, there's what's called offline evaluation. That's where we use that test set we put aside earlier to check its raw performance on things like accuracy. But here's the catch. Just because a model does well in the lab doesn't mean it's going to work in the real world. And that's why the next crucial step is online evaluation, where we test if the model actually moves the needle on real business goals, like improving user engagement or making more sales. And evaluation is never just about one simple number. The kind of mistake a model makes can matter a lot. I mean, think about a system that's assessing credit risk for a bank. A false negative, where the model mistakenly says a high-risk borrower is a safe bet, that could cost the bank millions of dollars. That is so much worse than a false positive, where a perfectly safe borrower gets denied a loan. You absolutely have to understand the real-world cost of every single type of error. So, the model has been built, it's been tested, it's looking good. It is time for phase 3, the launch. This is the moment of truth, where we release our creation out to real users. But, and this is a big but, deploying a new AI is not as simple as just flipping a switch. Yeah, you never ever want to just turn off the old system and turn on the new one for everybody all at once. I mean, can you imagine? If something goes wrong, and let's be honest, things often do, the impact could be disastrous. The key here is a careful, slow, gradual rollout. A really popular way to do this safely is with something called a canary deployment. The name comes from that old idea of the canary in a coal mine, right? So what you do is you release the new model to just a tiny, tiny fraction of your users, maybe just 5%. This little group acts as your canary. You can watch the new model's performance in a live setting, and if everything looks good, you can gradually, slowly roll it out to more and more people. And if it fails, well, you've limited the damage to just a small slice of your users. It's a super smart way to manage risk. Now, once it's deployed, a model can serve up its predictions in two main ways. First is batch mode. This is for when you need to process a huge amount of data, and it's okay if it takes a little while to get the results. The other is on demand. This is for all those real-time applications like a recommendation engine on a shopping website where you need an answer in milliseconds. The choice between them really just comes down to how fast you need that prediction. And that brings us to our final and maybe the most important phase, the long haul. You know, a lot of people think that once a model is deployed, the job is done. But the truth is, it's really just the beginning. A machine learning model needs constant care and feeding to stay effective. See, the biggest enemy of any model that's out in the wild is something called concept drift. It's a simple idea. The world changes. Customer tastes change, new trends emerge, the economy shifts. A model that was trained on yesterday's data will get less and less accurate over time as the world it's living in drifts away from the world it was trained up. And this is exactly why monitoring is an absolute must. You have to constantly track your key performance metrics. So for a recommender system, you'd be watching that click-through rate, the CTR. If you start to see that CTR dip below your target, like we see here, where it's dropped from 12% to 9%, that's a huge red flag. It's a clear signal that your model is losing its magic and probably needs to be retrained. So this all leads to a really crucial point. Maintenance is not a passive thing. It's an active, ongoing cycle. You have to just accept that performance will go down over time. So the best practice is to have a plan to regularly retrain your model from scratch using fresh data. And it is absolutely vital to keep everything, the data you used, the code, the model itself, all versioned and perfectly in sync so you always know exactly what's running out there in the wild. And really, that's the big idea here. A machine learning model isn't like a piece of software that you build, ship, and then call finished. It's more like a living system. It's a snapshot of the world at the exact moment it was trained. And as that world keeps changing, the real challenge, the thing we all have to think about, is how we make sure our machines can change right along with it. Constantly learning, constantly adapting, and constantly evolving. Thanks for joining me for this explainer.